would it be good to do a kind of a, well, not literally finite state machine diagram, but kind of like a kind of mission flow diagram or basic mission flow kind of state diagram? Just behavioral diagram.
Okay.
Might be
Is there
nice
any
to make sure
tool
we're
for
all
it?
kind of thinking about the same capabilities to kind of match up with how the components actually go together.
Yeah.
Is that what you mean?
Yep.
Yeah.
That'll also reveal behaviors and actions that have implications for the kind of electrical and mechanical system diagram.
What is there a tool for it, or do we do it here?
Why not here? This is a great place. It's got the stuff.
Okay.
It has triangles and squares.
And lines. Arrows.
Yeah, I mean, we could also do, like a swim lane or whatever. I don't know. I think Mayor, you really like Miro, right? That's a tool you use a lot.
I'm sorry, which one?
Is it Miro?
Miro.
Miro, okay.
Miro, yeah.
I've used it, but I actually haven't used it in a while. I like it for what's it called? Mind maps. It has way more capabilities, and I did use it for arranging squares on a page, but not that experienced. People here have been using Figma and Canva. I think that's what's traditional today. But yeah, this tool seems to have what we need, doesn't it?
Yeah, totally. I was just curious. For me, they all seem to blend together. Many of them lack sufficiently differentiating things.
How funny is it? Well, robotic arm picking up one of these squares and moving it.
Is Oh, did you post the link?
Oh wait.
Because we've been downloading and re-uploading to a new permalink, right?
I got the link by searching for Eric's message. I think the link in Discord should take you here.
Yeah.
Seems like something the machine here.
So, like, what's the day in the life of this rover?
At least 2 days, right? It's a beginning. Let's say we observe it for a weekend.
No, I think that's a good point. The first day or the third day?
Are they different? Is that a complete inner loop? Like, what's the largest time period we must consider?
I'm saying that we should start from the third day and then expand it to include the first day as well. Because on the first day that the rover arrives, it hasn't done any exploring, but it has a full battery. And it's not at a steady state. But after 2 days or so, it's going to be at some steady state, whatever that is.
I see. Why don't we say a week or a month? That's a very steady state.
You're super optimistic.
Well, do we keep observing it every day, like for a month?
Do we expect it to work for a month? In which case, I agree with Joshua. If we expect it to work for a weekend, then the second day.
Well, can we just refer to it as like day in, wherein it has some history, but it's not relying on having been charged via USB or whatever.
Yeah, like this thing is gonna be out there. Like it's gonna work for a month, absolutely. Maybe we'll figure out that there won't be much power budget to like move a lot, but it'll at least wake up and say hello. I mean, it's gotta.
So there's our behavior. It's got to wake up and say hello. What does it say? Who is it talking to? And how does it do it?
One thing that's certain is it will be sleeping, right? So I think this can be sleep. So this much we do know.
One thing would be an alarm, right? If there's something.
Can I
going
have a
wrong.
feeling for the budget? Why does it have to be sleeping?
Maybe sleeping is the same as charging, just like it's below its power budget. So
No, my
power
question
budget.
is maybe it's just not moving and communicating, but maybe it's still collecting audio data, or light levels. I'm trying to understand. Sleeping implies minimum power and maybe charging and maybe not. At night you just sleep.
Let's add another state.
No,
Yeah.
but can you give me a feeling for energy budget? Just, how much energy do we have? Let's just get a ballpark. Does it actually need to sleep? I agree. You definitely want it sleeping sometimes.
Yeah, I guess. I mean, okay. This is maybe bringing up an interesting point of a lot of how the firmware on a system like this is often architected. So like I don't know. Are you familiar with the notion of like an event-driven firmware? This is a very, very, very common way of dealing with a system like this. Or in terms of its behavior, you just talk about events that happen. You don't necessarily talk about like it's doing a thing. You say that there's the beginning of a thing happening and the end of a thing happening. So it's kind of like the edge transitions are what you are concerned with architecturally and in the actual firmware itself at the code level, as opposed to being in the middle of something. So like by default, in a system like this, it's asleep. But it wakes up on an event. And that event can be sensor input, stimulus, alarm, whatever.
That's good, but why should it sleep at all? What I'm saying is, if we can fit in the package enough battery, and if we're collecting solar radiation 10 hours a day, and that gives us enough power to power, let's say, the microphone for 24 hours, so why should we be sleeping at all? I mean, it's an option. There's a sandstorm covering your solar detector, you go into sleep mode. But in the steady state, when I say microphone, by the way, I don't mean a microphone that listens for events. I mean a microphone which is collecting data to be used somehow.
So sleep means like, does not do anything, or it's just waiting for something?
I mean, I'm just suggesting. So it's like, yeah, what are we?
So what we could have is like a deep sleep mode where it's doing nothing, and then like we could call the other mode a sleep mode, or waiting for something.
So like what actions does the rover take? Like maybe we could just start with sort of actions that it takes and events that happen in its life, because I think that'll maybe make this more emergent.
Okay.
So like actions, events. Yeah. Would that
Where
be good?
do I get the text box from?
So could it be moving forward?
So like
Is there a need to specify what communicating, in the sense that sometimes it's just communicating location, but some of the time is to communicate some other payload or stuff like that. For example, in a sleep cycle, okay, for example, there is low battery, so it's mainly sleeping, but maybe regularly it needs just to send its location. Okay, like every hour, it just sends the location and go back to sleep. While when it's in the main the scientific mission, let's say, it's communicating something else, like images.
Okay, I want to propose a mission. Let's call it. It's only half serious, but it's a mission, so we can change it. Let's say the mission of the Yakasaur is listening to grass growing and watching it as well. And basically, what it does is it sits somewhere and it's looking at some patch where there's a plant, and it listens to sounds coming from there and takes pictures. And if it hears a funny sound, maybe a bug coming by, so it wakes up more and takes more pictures. And if it decides that it hasn't found a plant yet, it can move around until it finds a plant. Okay, so I'm not saying this is the mission, but that's maybe an example of a mission that you can reasonably do for a month at a time. You're collecting scientific information, you have events that you react to, you do a little bit of moving around that's related to the mission, not related to keeping alive. So I'm saying it's not a suggestion for the mission, but that's maybe what a mission could look like.
So explore for a particular species of plant is the mission.
Not even a particular species, just find a plant, something sticking out of the ground, maybe it has to be a bit green or something, and then get close enough so you can aim your camera at it, so it's in the frame. And let's say you had a directional microphone which is listening in that direction, and you have predefined events. But again, I'm not saying that's a scientific mission. I'm just trying to explain a mission which makes sense for the Yakasaur, and which we can use to find an emerging way. What events do we have to react to, and what does it mean for the architecture? And of course, back home, we take whatever it sends and we compress 30 days into a 30-second clip. Yeah, because it's maybe boring. Slow.
Routine ops safe mode. Interesting. Routine ops. I guess for humans, that's sleeping. What is...
There's also routine sleep.
Do we actually need... I mean, what behavior change would be embodied by a diagnostic or safe mode in the field? It would be nice if the rover had a health check of some form, so it could perform a self-check.
We just had this rover satellite that its antenna got stuck and they managed to free it. That's exactly what you have to do. I mean, we don't not using any directional antenna, but let's say that once a day you check to see that your camera can move or that your wheels can move and that you're not getting covered with sand. So that's diagnostic. And safe mode, I'm sure there's several activities you could make. Yeah, that's a good example for a diagnostic. For safe mode, you can definitely imagine activities like using the motors which use up your battery. And in safe mode, you don't let any of these, dangerous activities go on, your data rate goes down, your maximum motor power goes down, or things like that.
But I guess, yeah, like we do have to define a mission at some point.
Yeah, well, that's why I suggested there's a mission I did, just so you could agree or disagree. But it seems to me like a mission. Okay, so you put your rover down, it looks around for plants that it can look at, takes pictures of it, listens to what's going on, transmits that. If suddenly a bug crawls by, it hears it or sees it, whichever one we decide, starts collecting more information and sending it out.
Do you want to lay that out in the diagram? So that would be measure, move, and then we're gonna measure. This is to take a photo.
Well, the first step is find your target. Okay, so the mission has a few steps. Step number 1 is find the target. Step number 2 is position yourself relative to the target. Step number 3 is ongoing monitoring and handling events, which has some substates inside. And step number 4, I guess, would be find a new target.
Okay, so is this the fundamental loop then?
I can't see the bottom one. Just a second.
So this is a fundamental mission loop.
Yeah, I'm having no. Sorry. Oh, this one. Yeah. Sorry. Yeah. Yeah. And step number 3, the measuring is event driven, in the sense that you're in a low powered mode most of the time, and in a high power mode when some exciting event happens.
Okay, so is that our mission? Is that our first mission at a high, very, very, very high low granularity level? And this could certainly be broken down into many, many more steps. Are there other missions?
But are we going to be in the Mojave Desert?
That's a great question.
And I'll tell you why I'm asking, because there's a very interesting, apparently, type of ant that lives in a desert, I forget where, maybe in Namibia, that has a particular time of day that it comes out, which is after it's too hot for all the other bugs, and then it goes out quickly, collects all the bugs that died from the heat and takes them home. So that's a different kind of mission. You have different insects coming out at different, let's call it, times of day or temperatures. And that, I don't know how much the Yakasaur can see, it's about, 5 inches high. So how far can it look? And how likely is it, to look at a spot where you have insects? But that could also be an interesting mission in the Mojave. And of course, listening to my grass growing, you can do in the backyard as well. You don't have to actually be in the desert.
Yeah, the ant tracking application is kind of interesting.
But you have to find them.
Yeah, you do.
And that means you have to follow them, and the power question. Now, normal ants start out new. forgive me for using the word normal, but the typical ants we know start out every morning and set out pathways, which I believe they use for the rest of the day. So depending again on our power budget, you could spend the morning hours looking for an ant trail. Once you find it, you can sit there and watch it and count, ants and what are they carrying or anything like that. But I don't know if you have enough power budget for, I don't know, going 10 feet in one day.
Well, I mean, remember the power budget? It's like it's a leaky faucet. So maybe the sun trickles in slowly, and you can use that however you want. So it's just a matter of waiting it out. If you need to do something that's going to be very power consumptive.
Yep.
So just as like one thing that's happening right now that's really interesting is we're talking about this mission and a few things are emerging. We're asking a question about, because we need to do an area scan. So that implies that there's a front-facing camera or a camera that can look into the horizon line. So that's one imaging and sensor location. And then if we're looking at ants or plants, maybe we actually need to have a downward-facing camera or a sideways or upward-facing camera. So it turns out we actually need two different cameras on the vehicle, which is now going to affect our system block diagram. And maybe we need to have stereo front-facing and then monocular down-facing perhaps is adequate. I don't know. For the whether or not it's in the desert, I do think this brings up the very interesting question about the flora of the deployment. Deserts are great because they don't have many plants necessarily to get in the way of the robot. So it's almost like it's an advantage.
Okay, Joshua, let me make this easy for you. The pavement in the city is exactly what you're looking for. You have big slabs, or maybe small slabs of concrete where nothing's growing and nothing's blocking you. And then you have, thin lines where you have plants sticking up.
Look, I live in San Francisco, and I have a lot of friends who built sidewalk delivery robots.
So they'll run over our robots.
If you set a robot down in San Francisco, it will disappear before you can turn around.
Well, if you have a walkway leading up to your house, I don't know if you have fences and gates, but
I don't live in San Francisco exactly. I kind of live Venkat I live away, kind of on the edge of the universe out here. But yeah, this does sort of like human interaction in terms of the plant inventory mission. That's not a required step in the mission. So maybe it's okay to be somewhere where there are no humans, and it's perhaps an advantage completely.
we don't want humans. They might steal us.
The robot appreciates solitude.
Botnap. But I think when you talk about the leaky faucet, the mission, one of the reasons why I suggested a plant is because the plant doesn't run away. If it takes a robot 10 days to find a plant, that's not a problem.
The anthill also doesn't run away, even though the ants do.
But finding an anthill is not easy.
That's a totally different scanning modality, right? So maybe it actually looks.
Yeah.
Please feel free to operate. I'm just.
I have no intuition on how you would find an anthill, other than you look for the ants and then you follow them back. Now it's easy for me. I have a lot of power to spare, and I can walk around, and I can use my binocular vision and my GPT-powered image processing. But our little Yakasaur is not.
So we're actually kind of moving and measuring at the same time, looking for an anthill. Is that what this behavior looks like? So this mission involves a lot of moving around because we can't see very well. Is that true?
Yeah, except for the part that before looking for the anthill, we look for the ant trail. Okay, we have like a sequence of operations. And the Yakasaur could indeed drop little bits of sugar in order to attract the ants. You know, it's not impossible. It's only a month-long mission.
A payload.
Yeah. So if you're going to go on a ant mission, so the right thing to do is drop, you know, a little bit of sugar water. The ants will find it. In the deserts, they'll just find water. And then you can find the anthill by tracking them.
Just mount a can of Coke on top of the Yakasaur.
Exactly. Yeah. Yakasaur.
So
Also acts as camouflage.
Yeah.
We could also get corporate sponsorships that way. I mean, the Yakasaur does look a bit like a Coke can with a handle attached.
Yes. So this is complete target found. So the transitions here are the events, right? That's kind of the core thing. So like the event happens.
How do I add?
Are you in here?
Yeah, I'm in here. I'm trying to add a circle from the last step to itself. How do you add a squiggly arrow? Is there any way a box can point to itself?
Oh, that's a good question.
Yeah, it's a good question.
Yeah, okay, here, you can.
You can, but then you just drag its little thing out.
Okay, how do I add text to it?
Just double click.
I should say target events. No, smaller than me. In this figure, the part that bothers me is the step of moving to target. I'm worried it's too difficult for us to fit in.
This could impose a requirement on the robot that it is tall enough to achieve an adequate viewpoint, or it has some sort of a higher viewpoint apparatus, like it's a giraffe kind of a situation. But then this immediately has cost and logistics implications if it's a larger robot. So the agriculture rover, the two-wheeled one that has been brought up before, that one is its geometry is directly driven by the mission and the parameters of what it measures in the mission. So that's tall enough to look over specific types of crops. So that's what I mean here is I'm not sure what is driving the dimensions of the robot from this mission plan.
Well, we have several different missions. Are we talking about the plant or about the insects? The plant is easy. We're talking about a desert and we're looking at small plants. So you have to be no more than this high up off the ground.
I guess it also depends what kind of desert. Is there well, it's only Venkatesh is the only one in SoCal. Right? Or no, are you wait, Rhett, are you in SoCal?
No, I'm in Seattle.
Oh, that's right.
Yeah, but even when you talk about deserts, there's a huge difference between the bottoms of a ravine, the sides, and the top of a hill. You know, in the desert, all of the soil gets washed down. So, depending where
point,
you are, you know, you have rocks, sand.
Yeah, my point's just the urban environment will not be friendly to this robot. So that to me just is kind of an automatic disqualification. The forest environment has so much brush and plant kind of flora that the robot, I think it'd have to be significantly larger in order to exist successfully in such an environment with the simple wheel design. And so I feel like that really leaves the desert as the only proper option. It also has this nice property of emulating many of the things in space we might go to, which are not friendly to any flora or fauna. So it's just rocks. So where can we go and just hang out with some rocks?
That
That was just my thread of thought. Does that make sense?
you can always put it in the middle of a closely cut lawn. You know, lawns are cut to like 1 inch, and that takes a place of sand. And as long as your wheels don't slip, you can go looking at a weed.
It's a dandelion tracker. No,
Exactly. You count bees that come to dandelions.
this is the new hot thing in lawn care. Yakima. Oh, that's true. That's true.
What about the pine forests? You know, pine forests usually have areas which have a lot of pine leaves on them and not a lot of plants. But they also have rocks and stuff, so the bot can just, you know, fall down.
I mean, the challenge there is we're competing for the sun.
Yeah. Well, in that case, it's desert or lawn. That's where you're not competing. Everywhere else, the plants, you know, they're growing. Tundra, but none of us live near the tundra, I think.
Yeah, I don't know.
Anuraj.
Sorry, what?
Maybe you live close enough to the tundra, you know, past the tree line.
There are small forests here, so like that have some sort of pineish trees.
No, but trees are bad because they block the light from our solar panel.
Yeah, so here in Finland, there would be almost no sunlight most of the year.
Yeah, so
That would make it really challenging if we are running on solar.
Yeah.
and there's also the beach if you're willing to compete with seagulls.
The beach is an interesting environment. Yeah, I mean, then you're kind of, what is this, a trash mapper? Or like, what sort of mission does it have?
It's the same mission. It's the same mission. You have on a beach, you have insects that come out at certain times. You have plants, little ones, bigger ones.
Yeah, I really didn't realize Washington has really
Every-
sort of arid areas. It's crazy. Okay.
Yeah, so I just started looking, and the rocket, like the model rocket launch site that's in Eastern Washington, is like a very desert scrub brush location. I wonder if that would actually make a pretty good. Presumably, rockets come down out there too. Model rockets.
What does scrub brush mean, though, in terms of obstacles and required size?
Yeah, I wonder how thick it is. I'm looking for pictures.
Okay, so let me put it like this. What characterizes that type of desert is a distance between individual plants. So you have bushes, but between the bushes, you have mostly empty space with whatever you have there, dust, hard rock, hard packed sand or whatever. So scrub brush could be a good place. Except after it rains, when everything, turns green.
Yeah. I don't know. The plant and insect mission does seem like a pretty natural piece of data to collect in these environments. I wonder which has more value. Maybe we don't have to know that yet, or which is more understandable.
Which one, if you send it to Mars and it's successful, gives you a wide recognition? Finding a bug or finding a plant on Mars?
Yeah, but it's like the core concept is all very similar, so it's a very good practice for a lot of the exploration missions, right? But I just mean there's we have satellite imagery of this planet that's pretty cheap these days, but we don't have any good sound data or high resolution images, like to the point that we could identify individual insects, which is also very interesting information.
There are some projects I saw on the internet where you're supposed to collect local soundscapes and send them in. But yeah, soundscapes are very complicated. They depend on the hour of the day, on the season. I don't know. Let's see.
There is a company selling a Raspberry Pi with a souped up microphone you could put in your backyard, and it would generate plots of birds that visit over time. I'm trying to find it again. That device used an incredible amount of power because it was running inference on the Raspberry Pi on the CPU. So it required wall power.
Okay, so I put here a link on a guy who made a map of sounds, posting recordings from all over North America. All over North America, several hundred recordings. But I think what I'm missing here is, why does it need to have wheels and move around? Okay, so I can just drop a IoT microphone. I don't need to have these motors if all I'm doing is collecting sounds.
We're building a sensor with wheels.
Yeah.
I mean, you could, that's what this is. It's a microphone that you could ask to slowly move a mile that way.
Can you? Is that your mission definition? Moving a mile that way, 100 yards at a time?
I'm just saying I do think that's an accurate and valid characterization of what the hardware can be.
I'm not
other
disagreeing. I'm asking. So you can add another mission. You can call it Soundscape Inventory Mission.
So like sound tiling, like we'll tile
Yeah,
ambient
exactly.
sound.
Exactly. And that, of course, makes the moving to target much, much easier. I mean,
depends how many
move somehow. But you can't do it anywhere except for the desert, a flat scrub brush because you get stuck on plants and snow and I don't know what.
Was that Raspberry Pi project identifying the birds, or
Oh, you found it?
what?
If you want to do a soundscape tiling, I think it would be helpful to add flying ability to the robot. And by flying ability, I mean something like a, helium balloon or something like that. And then you can measure, and then you can leapfrog to a new place. Or even hydrogen balloon. We collect sunlight and water, and we make hydrogen, and when we have enough, we move to a new spot. But that I think that's way beyond.
That's very complex hardware.
anything
Sorry,
you-
Anuj, did you say you found the project, or you were
No,
asking?
I was just asking what did that do? Did it identify the birds?
So it identified the species of bird and the time of day that it heard the bird, and then it generates sort of activity, and it knows the location. So you get location, species, and time, and you can plot all of that across a whole fleet of sensors.
So basically, the robot could move randomly in the forest, right? And then we could just log whatever animals it finds or birds it finds.
and
Yeah,
doesn't scare away.
there's oddly a number of projects involving collecting sound in weird places. So one of the organizations I'm familiar with is Rainforest Connection. They initially were trying to build a sort of a security system for the rainforest, and then it turned out that the scientific value of knowing where all of the birds are was pretty high. So here, I'll post it in the chat. But yeah, that because I have a friend who's a arborist, and he was helping them install sensors in like the Amazon in trees, because you can't just mount it on the base of the tree. You have to put it up in the tree.
Mm-hmm.
So that's an example of a high, well, I guess I would say high cost to install sensor that then it's immobile once it's in the tree. It seems like it makes more sense if it would actually it would be cheaper to just make a cheap drone that would
Yep.
like literally for just one flight to fly it up to the canopy, and then it would perch and grab on. That could potentially be cheaper than trying to climb the whole tree.
Absolutely.
So this is an interesting
That has
project.
the bread
The
truck.
one you posted, Yasha.
What was that?
Biodiversity monitoring. That seems interesting, right? So basically, they are doing the same thing, collecting acoustics in the rainforest.
Yes, that's what I'm saying. I'm just familiar with them. There's also other projects similar to this that, yeah.
Yeah, but
I haven't seen this one. This is some new hardware. Huh.
Yeah. So it's
That's
some
cool.
battery powered thing. Audio moth.
Oh wow. Oh, this is pretty impressive.
Okay.
Wow.
So they are doing some silicon labs.
how much does it cost?
Well, I think you can get a cheap, maybe for 10, 20 bucks evaluation board. Oh, this is expensive.
But it has a DSP peripheral, so it's doing live stuff.
How much
Cortex
power does it
M3.
give? No, it said it had a 0.9 micro. Oh, only 180. Oh no, per megahertz.
Yeah, that's a lot of juice.
So it's like
And
2 milliamperes.
Yeah, so I guess Venkat, that's really the opposite of what I'm saying. I'm saying the rover, like the actual locomotion part of the sensor, becomes so cheap that it's almost negligible. So every sensor is a robot versus this. Because the only reason you would want to separate the sensor and the mobility is if the mobility is expensive, which maybe it is here. I don't know. But it's like if you have a sensor and wheels are almost free, why wouldn't you just put wheels on the sensor even if you only use them once?
So let's say it's the other way around. We're not looking for a rover. We use the wheels only once, or we use the sensor only once. We're looking for some sort of mission where both of them are used over the length of the mission. Maybe not at the same frequency, but they're both continuously being used.
Yeah, this is. I did not see this board. This is really interesting.
They make some of these in Helsinki, here in Finland. So they have some stuff here.
And this is the one that's $90.
Yeah, the evaluation kit is no. I think this the entire thing. The evaluation kit for this is $99.
That's not a good reference. Yeah, because the EVMs,
Yeah,
the
they cost
pricing
more.
means nothing. They either basically give them away or charge extra.
Yeah.
There are no rules with the EVM.
Yeah, but you gotta assume that people making the Yakasaur are only going to buy one. So if they only buy one, it's going to be $99. Joshua, can go back to the yeah. Is this sufficient for all of our needs?
Yeah, it
Or
runs
do
a
we still
Cortex
have to add
M3.
a motor controller?
Oh, to use this as the
Yeah,
brain, the lizard brain?
add the everything. As much of the electronics as we can. I see it puts out blue balls. No, but that's not.
I mean,
Let's see.
there's the biggest
This is
thing is it.
specifically, yeah.
Yeah, it's not intended to be mounted to a motherboard. So if you want to integrate it into a system, you have to deal with all these wire harnesses, which is fine, but annoying. And then you have to route them, and it becomes a
No,
bit more
but we don't need most of these wires. We just need GPIO connected to the motor controller.
we have to be able to control our power consumption is the biggest thing. So if this module can control its own power consumption very well, which is not completely clear just looking at this.
They suggested that it could. At the very least, it has, power levels.
Right. So if it can go down into a low power mode, then the next question is, does it have enough I/O? And looking at the system block diagram will show us the required connections because it didn't have very many I/Os. It only had like 4 GPIO.
It only had 4.
Yeah.
But do we need more than that? We're not trying to build something, extendable.
We could refer to the system block diagram and look at our budget, our pin budget. So we need already, we need 4 GPIOs just to deal with load switching the big brain, and then the chip select pins for, it also doesn't have SPI, so we can't deal with the cameras. There's no SPI, so that's an automatic issue. Yeah, none of these are SPI or I2C. But is the design open source? Audio
So they have the data sheet. Doesn't seem like it.
That's a bummer. Yeah, that's a bummer. Oh, it says the firmware.
So firmware is there, but not the actual like schematics and stuff.
Yeah, we don't have to have a camera if all we're doing is listening.
Most of the missions that we've discussed today involve some element of image capture or capturing an image to facilitate navigation, or it does seem pretty clear from today that there's going to be a pressure to have image capture of some form, or even multiple cameras even. Is that not true?
That's a mission that we gave because we gave it a camera, but maybe we can give a different mission. It walks around on the grass listening for cockroaches.
I don't know. I would always say core capabilities, add them on initially and then remove them, descope them if they turn out to be redundant or excessive. But yeah, this definitely cannot support the camera modules. But maybe it could be used as its own module. I mean, can you talk with it?
They also have a GPS board, I saw. If you scroll down a bit more. This one here.
Yes, you add it
Yeah,
to on the board, on top of the board.
I'm sorry. I also didn't mean for this to be like a whole rabbit hole. It's just I knew Rainforest Connection. I didn't know they were using different hardware, and it's very cool that somebody did this because it's interesting for science. Sound mapping.
What is a
Mayor-
micromorph? Can you show us a micromorph for a second? Open source design. I mean, if we're talking about a module.
So it has a mic, just the mic and the controller and some.
No, it also has a storage for storing the
Yeah.
recording. That's very important. If the main stuff, in other words, instead of having a central memory, we have the microphone has a memory, and the camera can also have a memory.
If they have the hardware design public, that's very cool because maybe that could just get put right into the project and it could go on.
They say it's open source.
They keep saying that. Yeah, is it?
Yeah.
But a lot of people say that, and it's just the firmware, not the hardware.
By the way, they have a very interesting point here that they attach using glue, not using screws. I mean, you can. So how much, if the micromorph is cheap enough, we can do what Venkatesh wants, where you have the mothership walking around and dropping micromorphs.
If it's important that we have audio from multiple places at the same time, this does constrain this notion of having multiple sensors because we can't be in more than one place at a time. So $80. Wait, what is? Wait, this is.
I think they have the waterproof case with this price.
This is an active campaign, or this is?
This seems to be active.
Huh.
But seems they make money via the hardware.
The micromorph also has 4 GPIOs. But it doesn't have much memory.
So we are at the hour. I would suggest having a guiding North Star mission. It's as simple as possible. Should we be audio only? Cameras, both? Are we looking for plants or insects or both?
Or soundscape. Or just soundscape.
The sound tiling is kind of an interesting...
Sound tiling, yeah. So I suggest we quickly draw up a square for sound tiling, like the one for the plant and insects, just so we don't lose it.
I didn't... You want to draw it up here, or...
I'm not that proficient with this tool.
Okay, so this is sound tiling mission.
At the risk of being boring, another simpler mission would be to say, we just want to move and survive and communicate our whereabouts.
But that is that's a sub task in all of these so far. The survivability
Right.
and basic movement, that's a mission that we will definitely already have and need to achieve.
Right. So if we did nothing else besides that, that would be a huge accomplishment, I think. Everything else is kind of gravy.
Let me try.
Yeah.
2 new... Wait. So we actually need to collect audio. Okay. Then we have obtain position in SS. This actually probably happens first. We need to know where we are. We need to move to that position, and then we inventory it, because when we're dropped in, we won't know where we are yet. Or rather, we should not assume that we are in position to take a sample yet.
I would assume... I don't know what you mean by in position. Collect audio.
Like the tile location.
Here. I'm here. You know?
Well, I mean, don't we want to go to the centroid of the tile, or do we not particularly care? You're saying it's more of a
this word tile that you're using, you put the rover down, that's the centroid of the tile. You move a yard or 2 yards or whatever it is we think we can move, that's a new tile.
This is here you had this one. This was
it's just kibitzing. I would switch the collect audio with move to new target. That's all.
Oh, I see. Oh, because I get. So I guess what you're proposing that we don't particularly care about going to a pre-planned map. We're going to self-form the map in a more lazy way.
Stage of the game, that's what I'm proposing. Yeah.
I see. So then the collect audio is the first initial step, you're saying?
No, you obtain the position. I agree. No, you obtain the position.
Oh.
Okay, you got to know where you are.
Like this, yeah.
So Vet, I think people have to have a reason for doing it more than just it beeped.
It's gonna beep.
No, but Vet said it just has to stay alive. Staying alive, we're assuming, is coming from the fact that the rover is well built, not that the rover knows how to deal with sudden changes in sun, wind, or rain, or a passing coyote. I mean, it's a different mission. The mission of stay alive against nature. Is that the mission you're proposing?
And move and migrate, like to travel distances. Yeah. Like, even just to be able to design, like to have a rover that could travel 200 yards in a month on solar power might be a lot. I have no idea.
I do agree with Venkat that the interestingness and the challenge are kind of independent. You can do a really simple but extremely exciting thing, or we could do a complicated but not exciting thing. Like those can exist at the same time. But like any of these involve it doing a thing. It's like, isn't that true, Rhett? That like these are all. I mean, yes, they sound like a lot, but there will definitely be many goals achieved along the way. So it's like the first mission is it sends its first telemetry from the desert. If that's our mission, then we're we're going to be doing that for sure.
And that's like the Sputnik level, right?
Yeah, exactly. Exactly.
Yeah, and I don't mean to say that like, oh, the simplest mission is accomplished and then now the project's done. I'm thinking more along the lines of iterating towards greater and greater missions.
Okay, maybe I can make a suggestion. When we look at the sound tiling mission, imagine that we don't have a camera, and instead we use a GPS in order to correct movement. Okay, so that is just moving, and it is not trivial. Okay, it's interesting. I'll call it that for a second. And we just added the mission of collecting sounds. But if you don't have a camera, moving around and making sure you moved in something like a straight line becomes, that much more difficult. And the GPS is a power hog. So again, you have to.
It sounds like the great thing about putting cameras on this robot will be that when they fail, it will still have a mission.
A microphone does that too. Oh, I'm listening to the wind whistling through my broken wheel.
I mean, when they put a microphone on the, on the Mars rover, like that was pretty cool. It was like, oh, we're listening to what Mars sounds like, but not as cool as a picture.
Yeah.
Well, great. Is this? I feel like this was really actually very good progress to understand. And then we can look at this more closely, and it'll verify the sensor suite, because we'll think about things like, oh, the robot has to have an IMU to detect what orientation it's in when it's blind, and that kind of stuff.
Yeah, I think having the reasons why you might actually need two cameras are also particularly, I think, enlightening. Like, oh, if you were doing ground observations and navigation, well, you're going to need both as two different cameras.
Yeah, it's definitely more cheap, more robust to put two cameras on instead of a camera plus an actuator to move the camera. At least
You have the wheels. If you want to move the camera, you can move the whole rover.
one could certainly put the camera on the wheels, but the issue is right now the wheels are.
And I turn the wheels in opposite direction. The rover turns.
Yeah, but it's like if you put the camera on the wheel, it can look at either the sky or the ground, which is kind of an interesting property. But
no, I put it on the body, facing forward, and I can only move in a horizontal plane.
Right. Yeah. Okay. We are over though. For next week, do we want to keep doing a block diagram, or? I would actually also I think it'd be interesting. Maybe we could try a format where we kind of independently, it's just like a co-working hour for some of the subsystems. So like we could do some MCAD, we could do some part selection, some board layout.
I think doing some part selection would be particularly interesting if we could move towards a breadboard type, something physical. Might be kind of nice.
Cool. So maybe next week is part selection and get the final bomb done.
Okay.
Cool.
All right. Cool.
Okay. Bye.
See ya.
Thanks, everybody.